Welcome back, everybody. We're going to continue this week's discussion about dependency injection. We're going to talk a little bit more about what it is, why we use it, and how we get it all sort of set up correctly. So first off, we have to actually define it. We've used it already. We used it when we talked about solid, but effectively, a class says what it needs, not how to get it. All it does is define what it needs. So this allows us to keep our classes loosely coupled and easier to test. For example, here we can see a tightly coupled class where it says like payment processor, private payment method equals new credit card payment. This is the class defining what it needs, the payment method, and defining how to get it through this new credit card payment. Now when we instead use dependency injection, we have this loosely coupled model here where instead we define what we want, a payment method variable, and then our constructor will get it passed in. We don't know how we're going to get it. We don't know what it's going to look like. We just know it will be a method of type payment method. So every single time we use the new keyword, we're looking at some kind of a chain effectively, right? We're tightly coupling our code together. Sometimes it's unavoidable, but we really want to make sure we're thinking about it to ensure that we're using it responsibly. So we can see here that anytime we say new inside of a class, we are hard coding a dependency. That is what's happening here. And maybe that's okay for something like a linked list, but maybe it's not okay for something like a credit card payment. It does make it effectively impossible to swap the implementation out without having to go in and actually edit this class, which doesn't make a ton of sense. We shouldn't have to edit this payment processor class just to change the payment type. They should be two totally decoupled, two totally separate pieces. Right, this breaks testability and it creates really rigid code that's hard to maintain. So here we can see an example of a user manager service. It has an email service variable inside of it, and we have this new email service, and we are tightly coupling our user manager with our email service so that register user can now pass in the email and send a welcome email. This could be refactored, and we can see that what we could do instead is completely decouple them, where we have an email service class up here. Our constructor will take in an instance of an email service, and now they are two separate classes. Of course, the user manager is still tied to this concrete class of email service because now we're stuck always sending whatever this message is by email. We would be really stuck if we wanted to send this message by SMS text, for example. So if we wanted to make this even more flexible, we'd want to take it one step further. And we've seen this already. We want to implement this interface sendable with this send with the message and recipient. We want to have our two different types of email services. We've got a sendable one for email service here, SMS over here. These are both classes. We can see that the code sort of for each of them actually lives within these two classes. And now we can pass in this user sendable over here for the user manager. It will set it in the constructor using dependency injection, and then we can just say sender.send welcome message, and this is going to automatically send this message according to whichever email service we set up. So there are tons of benefits to dependency injection, and a lot of this is just a very quick recap about them, right? We can swap our real dependencies for mocks and fakes in our unit tests. So we can define all new classes that implement the same interfaces as our real ones and use them for testing. And this allows us to ensure that no external systems or side effects get in the way. We've already seen this done in testing examples in previous weeks. We also get cleaner wiring, right? So the classes are not creating their own dependencies. External code wires all these pieces together. And when we talk more about things like factoring methods, we'll learn about how we can be doing this through these external code sort of mediums, so like a factory method, or there's also some dependency frameworks like Spring is another option. So it sort of depends on how you do it, and it's certainly necessary if you're trying to deploy code to a website that you want to both test locally and then deploy somewhere in the real world on the internet. So we need dependency injection to solve this problem so that we're not constantly having to manually remember to change our code. Effectively, it means we get to put a central place for those configurations, like if we're local, use this. If we're on production, use this. Those types of configuration setups. When it comes to the best practices involving dependency injection, we want to make sure that we know that we prefer constructor injection over a method injection. So if we do know that we're going to need a instance of a class within another class, within an object, it is preferred that we actually have an instance variable and we inject it into the constructor. It ensures that we're making our dependencies explicit and ensures immutability of our dependencies, because if you pass it in through a method, the next time you call the method, you could be using a different dependency. So rather, we want to make sure that we are keeping it immutable. We always want to be injecting abstractions, not concretions. So previously we saw the example where we were injecting the email service, but that was a concrete class. We don't want to do that if we can avoid it. Instead, we want to pass in the interface sendable. We want to group related dependencies into a single service, right? So we've talked a little bit about this idea of data clumping, and if we have a lot of parameters, we want to do our best to sort of clump them all together and put them into a class. We also really want to make sure that we're using the dependency injection frameworks that exist wisely. So we want to let them do their job, let them wire things up, and keep logic in our code. So we really want to make sure we keep those separate. If we do need logic, it should be in the code base, whereas the configuration frameworks are just in charge of wiring all the pieces together. We don't really use any DI frameworks in our course, but you will see them in 4350 Software Eng 2 if you decide to take the next one. On the flip side, we're going to look at the pitfalls. So the first is, of course, that I give you a hammer and everything looks like a nail. We have this problem of over-injection. If we have dozens of dependencies in one class, we end up with a really smelly designed code, right? Or really smelly code. We want to make sure that we're still being very careful and using this when it's appropriate and the appropriate amount. And the next is the setter injection as default. So I already mentioned we ideally don't want to be using setters as the way of doing dependency injection or passing it into methods. We want it to be in the constructor, and that is to help us avoid this like mutability versus immutability bit. If we pass something in that is mutable, that can be changed, we could be passing around invalid states, we can't maintain our validation on it. We want to ensure that we keep those as decoupled as possible while still maintaining the data's integrity. So ideally, we don't do setter injections. We're doing it in the constructor whenever possible. The next one is injecting config data everywhere. We want to make sure that we're not sort of effectively over-injecting, right? We kind of already said that. We want to pass through a single configuration object, get everything nice and wired and set up. We don't want this to sort of become something that we lean on too heavily, pardon me. And then lastly is treating dependency injection as magic, right? We still need to understand object lifetimes, the life cycle of our data, the memory representation and how things are, like how long things are alive, right? Their lifespan. It's not magic. We do want to make sure we really understand it so that we can use it most effectively. To end off our kind of quick video here on dependency injection, a lot of it should have been just sort of a review. We're going to have this pause and reflect here, right? We've talked about this actually already, but we can further solidify it. Go into your projects, pick a class in your project, and let's refactor it to ensure that it receives its dependency via constructor injection. So this could mean going into a class that has methods that have dependencies, and instead of doing those dependencies in the method or passing it into the method, we pass it into the constructor. Or it might be something even simpler. We're currently setting new in the constructor. We want to not be doing that. We want to be passing it in, right? So perhaps you haven't applied this to your database manager or your connection yet. This is the perfect time to sit down and go do that, right? Because this way we can imagine that we're swapping our real database in for like a mock or a fake database for testing, or maybe even like a different database model. There's a little bit of extra work involved if it's a totally different model, but perhaps we even think production versus testing versus development versus unit tests, right? We have all these different sort of instances of our database and the things that we can do with it. We want to be able to swap them in with relative ease. So the goal is to make our code swappable, testable, and flexible. And as much as possible, we're not setting new inside of our methods or constructors. Okay. This quick video is all done, and I will hopefully see you in the next video with a little bit of refactored and dependency injected code. Thanks everybody. Bye.